So guys, we move forward to the next lesson, interior and exterior angles of polygons. So the interior angles of polygons, as you can see here, let's say for example, we have here a figure, okay, a triangle. Okay, so in the triangle, the interior angles, of course, are the angles that can be found at the center of the triangle. Okay, so those are the interior angles. Okay, so we have here a polygon interior angle theorem. The sum of the measures of the interior angles of an N-Gon is equal to n minus 2 times 180 degrees. So what does that mean? For example, we have here a triangle. Okay, so n there symbolizes the number of sides that it has. So a triangle has 3 sides. So we can simply substitute n. So n minus 2 times 180. And what's our n value? So that's 3. 3 minus 2 times 180. So 3 minus 2 is simply 1 times 180. Therefore, you get the measurement of a triangle, which is 180 degrees. Okay. So let's say, for example, we have a, like a decagon. So a decagon has 10 sides, okay? So if you substitute 10 there, so that's going to be n minus 2, so that's going to be 10 minus 2 times 180, okay? And then 10 minus 2 is simply 8 times 180. So that means the sum of the interior angles of a decagon is 180 times 8, so that's 1440. So that means it has 1440 degree angles as the sum for its interior angles for a decagon. Okay, so let's move forward with this example. We have here a hexagon. Okay, so given hexagon H, find the number of sides, the number of triangles formed, sum of the interior angles, x, the measurement, sum of the interior angles, x the measurement of each angle. Okay, so we have here given a okay, so given a figure here, we have here the figure or the shape hexagon. So given hexagon H, find the number of sides, number of triangles formed, the sum of the interior angles, the value of x, the measurement of each angle, and the number of diagonals in hexagon H. So we're simply going to find 6 different values, okay? So let's start with the easiest one, so the number of sides. So the number of sides of this polygon, okay, so that's a hexagon, hexa, meaning it has 6 sides. Okay, so that one was pretty easy. So number 2, the number of triangles formed. Okay, so we have the formula n minus 2 times 180. For the sum of the interior angles of the polygon. Okay, now we have here n minus 2. N minus 2 is actually the number of triangles. Okay, to get the measurement of the entire interior angles of a polygon, you have to multiply the number of triangles that there are in a figure times 180. That's how you get the sum of the interior angles for any polygon. And for this problem, we have n minus 2. Okay? So this is the total number of triangles in any given polygon. Okay, so for this polygon, we have the number of sides that we have. The value of that is 6. Okay, so we simply substitute 6. 6 minus 2 is simply 4. So that means there are 4 triangles in hexagon H. You can form 4 triangles there. So let me just show you how we can do that. Okay, so let's look. 1, 2. Okay, then we can do it like 3. Okay, so for this figure, it has 4 triangles inside of the polygon of the hexagon. So how can you visualize that? Where are the 4 triangles inside hexagon H? So I'm going to show you. So here's one triangle here, and we also have 1 triangle here. Okay, so in the center, if you notice, we've made a polygon or another polygon, so that's a rectangle. And if you divide that rectangle into 2, then you get 2 more triangles. So we have 1, 2, 3, and then 4 triangles for a hexagon, for any type of hexagon. Okay, then we have the third one. we need to find the sum of the interior angles. Okay, so how do we find the sum of the interior angles? So the formula, again, okay, so let's use white so it can be more seen, more visible. Okay, so we have here the formula for the sum of the interior angles is n minus 2 times 180. Okay, so what's the value of n again? So that's 6 minus 2 times 180. So to get the sum of the interior angles of the polygon, we simply have to subtract 6 minus 2, and that's 4. Subtract 6 from 2 from 6, so we get 4, times 180. So 180 times 4 is simply 180 times 4, so that's 720. So that means this polygon right here, this hexagon right here, has an interior, the sum of its interior angles is 720 degrees. Okay, so let's move forward to the fourth question. So this one is getting more difficult. We need to find the value of x. Okay, so if you look closely, guys, if you look closely, students, so this is a hexagon, and what you can see here is you can see marks. Okay, so these marks, so if you see this first mark, second mark, third mark, fourth mark, fifth mark, and sixth mark, that means their sides are congruent. Okay, so if their sides are congruent, it follows, if all of their sides are congruent, it follows that all of their angles are also congruent. Okay, and therefore we have here a regular hexagon. A regular hexagon is a hexagon that has the same number of sides, the equal value for its sides, and also an equal value for its angles. Okay, so how do we solve for the value of this x? How do we solve for the value of x? So it has 6 sides. Okay, so we can write there 6, and all of its sides are congruent. So we simply multiply 6 by 6x minus 2, since this is the side, okay, that's given to us, is equal to, okay, so this value here is the value of the angle. Okay, it's the value of the angle. So this value right here is equal to, so it means it's equal to the entire sum of the interior angles of the hexagon. And we already solved that a while ago. Okay, so the value for that is 720 degrees, this one. Okay, so this is the value that we're looking for, and what that we have solved for, it's 720 degrees. So we simply substitute that 720 degrees here in our formula. So we have here 6 times 6x minus 2 is equal to 720 degrees. Okay, so that's 720 degrees. So we're just going to do some bit of algebra. Okay, so 6 times 6x, so that's simply 36x. And 6 times negative 2, that's simply minus 12, is equal to 720 degrees. Okay, so what we're going to do is 36x minus 12. So we're going to transfer that to the other side. It will become positive 12. So 720 plus 12. So what's 720 plus 12? So that's 732. Okay, 732 divided by 36. Okay, so to get the value of x, and then we get 732 divided by 36, we get 61 over 3. Okay, now we have the value of x. It's actually, x is equal to 61 over 33. And if you simplify that, and if you want to make that into a decimal, so you're going to get 20.33. So that'll be 20.33 bar. So that's continuous. So we want to find, okay, so we found the value of x here. So the next step is we want to find the measurement of each angle. Okay, so the measurement of each angle is already given there. It's 6x minus 2. But we want to get the specific measurement or the exact value. So what we're going to do here is we have to substitute the value of x. So we're not going to substitute the 20.33. Okay, because that is an estimation. What we're going to substitute is the fraction, the exact value, which is 61 over 3. So what we have here is 6x minus 2. So we're now solving for the measurement of each interior angle of the hexagon H. 6x minus 2 is equal to the measurement of each interior angle. Okay, so each interior angle measurement. So we simply substitute 6. We substitute the value of x, which is 61 over 3, minus 2. Okay, so you simply cancel that. So that's going to be 2 times 61 minus 2. And what's 2 times 61? That's simply 122. Okay, 122. And then minus 2. Okay, you get 120 degrees. So that means the measurement of the entire of each interior angle for this hexagon is 120 degrees. So we can solve that. We can actually solve or check. We can check if this answer is true. So we have here 120 degrees, right? That's the measurement of each angle. But we have here 6 sides, okay? And therefore we have 6 angles. So the measurement again for all of the interior angles of a hexagon is 720 degrees. So to check whether this 120 for each interior angle is correct, we simply multiply that by 6 to this number because we have 6 angles. So 120 times 6, if you multiply that, most likely you are going to get 720 degrees. And that proves our answer. Therefore, the measurement of each interior angle for hexagon H is actually 120 degrees. Okay, so lastly, you want to get the number of diagonals that we have for this figure right here, figure H or hexagon H. So to get the number of diagonals, okay, the formula is simply n times n minus 3 all over 2. Okay, so what's the value of n here? That's the number of sides, so that's simply 6. So 6 times 6 minus 3 all over 2. So that's going to be, what's 6 minus 3? That's simply 3 times 6 all over 2. And what's 6 times 3? That's simply 18 over 2. And 18 over 2 is simply 9. Therefore, there are 9 diagonals for hexagon H. 9 diagonals for hexagon H. Okay, so that proves our final answer. So we have here for this specific problem, so we have here, it has 6 sides, it has 4 triangles, the measurement of the sum of its interior angles is 720 degrees. The value of x is 61 over 3, that's the exact value, or if you want to approximate, that's 20.33. The measurement of each of the interior angles is 120 degrees, and the number of diagonals is 9 diagonals. Okay, so that's it for solving for this problem on interior angles.